Okay. Did you send me a copy in our first session? All right, let me see if I can find that and open it up. That might be the easiest way to do this. I'm looking for it. I don't see it. Oh, there it is. Brianna Ellis. Do you happen to know which one it is? I got image 1 and image 2. Let's see. This is looks like the second. Is that what we want? This is the front side. Okay. All right. Let me see how many times I can blow this up without it rotating. There. Perfect. Where do we want to begin? Okay. So I'm just going to write over here on the right side. I'm going to write what we have there. 2a is y equals x squared plus 9x minus 7. Now, they want you to put it in vertex format. What's vertex format? Y equals what? It's a times, that's okay. That's vertex format right there. So we're trying to put this function into this format. And the way you're always going to do that is by completing the square. All right, so what's the first step in completing the square? Leave space, because this is where you're going to complete the square right there. Okay, and then we have minus 7 still. Okay, now, in other words, again, notice that we have not changed the original function. And that's key. You don't ever want to change the original function. You can't, otherwise you are no longer working on that function. So, how do I complete the square inside the parentheses? Okay, so what is that? Give me that. Perfect. Now, I've just changed the equation. What do I have to do to get it balanced? Yeah, now that is exactly the same as that. I haven't done anything. All I've done is add numbers and subtracted numbers, but I still have my x squared plus 9x minus 7. Okay? But the fact that I have completed the square allows me to write that how? Perfect. What's all that equal to? So over here in the upper left, we have minus 7 minus 81/4. How do we do that? Good. Find a common denominator, which is 4. Okay. Now what? You got minus 28 fourths, minus 81 fourths. There's your answer. That is in perfect vertex format. What's A? What's A? What is A? Okay, what is H? No, it's minus 9 over 2. It's always the opposite sign. Remember, you're always dealing with an x minus h. Okay, so what is k? Yeah, and that's perfectly fine way to leave it. You do not need to turn that into a mixed or proper fraction. And in fact, you can't even reduce it. I can't divide top and bottom by anything. So 109 over 4 is the simplest fraction you can get there. All right. Okay. Okay. Now, this says solve this by taking square roots. What's the first step? Okay, tell me the next line. And the next line. Good. Now, is the square root of 90 simplified? Okay. What is the square root of 90 equal to? Over here on the left. Good. Which becomes what? No. What's that equal to? In other words, the reason you broke it up into 9 times 10 was because 9 is a perfect square number. Well, what's the square root of 9? That's the simplified version of the square root of 90. So we have this. And you always have to do this step. You will lose points. It's like giving an answer of 12/24. You will always lose points with that answer. That answer should be 1/2. Okay? Same thing with radicals. If you do not simplify it, you're going to lose points. So you always have to simplify it if it can be simplified. Now let me just test you a little bit on that. What's this equal to? What's the square root of 10? Simplify 10. Five and 2. So this is the best you can do. But that is 2 terms as opposed to 1. So that is not considered simplification. In other words, square root of 10 is equal to the square root of 10. That's as far as it can be simplified. But square root of 8. That can be simplified. What's that equal to? Yeah. Notice, square root of 8 always is simplifiable. Square root of 10 is never. How about square root of 48? check it for divisibility by your perfect square numbers. Okay, let's try 4. What's the other one? Okay, so that's 2 root 12. But what is root 12? Now you have another 2. So the whole thing is equal to 4 root 3, correct? Notice that it took us 4 steps to get there. Had I noticed that 16 is a factor of 48, then I could have said 16 times 3. And immediately, in one step, I get to 4 root 3. So it's always more efficient if you find the highest perfect square factor. But you can always get to the right answer by just finding a perfect square factor. In other words, even though 4 was the first thing we saw, we still got there. In other words, that was just an intermediate step, 2 root 12. Well, that becomes 4 root 3. So we still get to the right answer. So it's not like you have to find the highest perfect square. It just reduces the number of steps. In other words, if you happen to notice that 16 is a factor of 48, you'll get there in one step. If you don't, and you notice that only 4, you'll still get there. You just get there in more steps, which is fine. Okay? So you don't always have to find the highest perfect square. You just need to find a perfect square factor and then keep going. And I'll always are looking for a perfect square factor. All right. So go ahead. It's just a calculator problem. Well, let's talk about this problem because I do want to point out something. Because most people make a mistake when they do this. And let me help you avoid that mistake. First of all, this is very straightforward. There's nothing mysterious about this, okay? But what happens is this 3 is frequently a negative 3, and people make a mistake figuring out the discriminant. That's the discriminant right there. The discriminant is b squared minus 4ac. It is not the square root of that. It is b squared minus 4ac. Okay? So, I suggest to everybody that you do these 3 numbers first, and then you subtract it from 30 squared. So what's 4 times 5 times 3? Okay, so we have 900 minus 60. Right? So now that whole thing turns into minus 30 plus or minus the square root of 840, all divided by 10. Now, what are we doing? Using your calculator. I hate this problem. I really do. No, I do hate it because if you're going to use your calculator, well, then you go directly from there. Your calculator will tell you what the square root of 840 is. And you're going to have negative 30 plus the square root of 840 divided by 10, and you're going to have negative 30 minus the square root of 840 divided by 10. Those are going to be your two answers. So as long as you're using a calculator, this problem is very straightforward. However, let's pretend we're not using a calculator. If we're not using a calculator and they want their answers perfect, notice that a calculator will never give you a perfect answer here. It will give you an approximation. If I want a perfect answer, I have to leave it in radical format. So let's play with square root of 840. What's that equal to? How about, let's look at our perfect squares. Is that divisible by 4? Okay, that's a good place to start. You might check one step up. Is it divisible by 9? You know how you can tell if a number is divisible by 9? If the digits add up to 9. Always. These digits add up to 12. 3 if you keep going. So there's no way that number is divisible by 9. So I'm going to assume that 4 is the greatest factor. What's the rest of it? Okay, so that becomes 2 root 210. Now the question is 210 divisible by anything? Is that divisible by, it's not divisible by 4 because 10 is not divisible by 4. In other words, every number that is divisible by 4, the last two digits have to be divisible by 4. Doesn't matter what's in front. You could have a 7-digit number. If you want to know if it's divisible by 4, check the last two digits. So this is not divisible by 4. It's not divisible by 9 because the digits do not add up to 9. Yeah, but that's not a perfect square number. So that doesn't help. In other words, I could make it 3 times 70, but then I still have two things that can't be. In other words, the only time you want to simplify it is if you can pull a perfect square number out of there. And I don't see it. I don't think it's divisible by 16. Definitely not by 25, not by 36, not by 49, not by 64. That's when I stop checking. Okay? So that appears to be the answer. Now let's go back and plug that in. So we have 2 square roots of 210. So I have minus 30 plus or minus 2 square roots of 210 all over 10. That actually does help in simplifying this entire expression. What can I do now? I want to divide top and bottom by 2. And you can always do that because what you're doing is dividing by 1. I can divide or multiply this entire expression by 1 and I do not change its value. So if I divide top and bottom by 2, that's dividing by 1, right? So I'm going to have minus 15. Well, it gets rid of that 2. And in the bottom, I got 5. Now, is that simplified? Yes. Well, I know what you're thinking. You're thinking you can divide top and bottom by 5. But you can't really. You can't. Because in order to divide top and bottom by 5, I got to be able to divide that by 5. And that is a 1. So I cannot divide top and bottom by 5. And I'm left with what I've got. Minus 15 plus or minus root 210 all over 5. That's the final answer. You never use I unless that you're taking the square root of a negative number. This is the square root of a positive number, 210. Doesn't matter the size of it. You do not use I unless you have a negative number. What did I do? No, I'm fine. Yeah, no, I did everything right here. Okay, all right. Let's see. Got 10 more minutes. Tell me what you would like to work on in that 10 minutes. Okay. These are pretty common problems. When you're looking at a problem, this is projectile motion. Doesn't matter whether you hit it straight up in the air or whether you hit it in an angle. If you go out and you hit a baseball and it goes at an angle, goes 200 feet, it's projectile motion. The function for projectile motion is the height is equal to, this is meters per second, so it's minus 9.8 t squared. If it were feet per second, that would be minus 16. Excuse me, it's minus 4.9. Plus the initial velocity times t. What's the initial velocity? Times t, which is the time that has elapsed, and the height is the last number, 2 meters above the ground, so plus 2. So there is our function, and I made one mistake here. It's not h of x, it's h of t. What that tells you is that it's a function of t. It's not a function of x. It's a function of t. In other words, the variable that I'm going to find on the other side of the equation is going to be t, not x. Okay? So that is the quadratic that controls this motion. Now notice quadratics, that's got a negative coefficient. So we're probably looking at something like that. Now, the fact that it goes straight up and down doesn't really matter at all. In other words, projectile motion works whether you're going straight up and down or whether you're going at an angle. That's physics, okay? But you get it here. Okay, so write an equation that models the position of the ball at time t. Really should not say the position. It should say height. That's why it's called h of t, for height. Because it's not really the position of the ball. In other words, it is because we're going straight up and straight down. But if we were going like this, you would not want to say, what's the position of the ball? You'd want to say, what's the coordinates of the ball? But because we're going straight up and straight down, they can get away with saying, what's the position of the ball? Okay? So, but this still means the height. Okay? So, write an equation at time t. We've just done it. That's it. Use h to represent height and t to represent time. That's fine. Find the ball's maximum height. Okay. What are we looking at? We're looking at what kind of a shape? Okay. Let's pretend the parabola looks like that. So what am I looking for? To find its maximum height? The vertex. Yeah. Now, if what we're really trying to find is the y-coordinate of the vertex, we have some simple formulas to find the x-coordinate of the vertex. Is t equal to at the vertex? Here, let me write it like this. The vertex occurs at what time? What's the formula? It's the first half of the quadratic formula. What is it? No, the first half is just that. You see why I call that the first half? Okay. In other words, if I were to separate the quadratic formula into two fractions, this would be the first one. It'd be minus b over 2a, and the next one would be plus or minus the square root of the discriminant over 2a. But when I want to find the vertex, and I'm looking at a quadratic that is in standard format, the easiest way to do it is to use this formula right there. There's numerous ways to do it. We could complete the square, but you can see that that's going to be hard. We're dealing with fractions and decimals. To complete the square, I'm going to have to factor out a 4.9, and then I'm going to have to take half of whatever that is and square it. I'm going to be dealing with monstrous numbers. So completing the square is not the easiest way to find the vertex here. What's the t-coordinate of the vertex? This is the t-axis. This is the h of t-axis. So what's the t-coordinate? What's minus b over 2a? Well, don't use a calculator. Just tell me what it is. What's minus b? What's b? Now, don't look at your pages. Look at this function right there. What's b? That's in standard format. Oh, that's a. 4.9 minus 4.9 is a. 24.5 is b, plus 2 is c. So minus b is minus 24.5. What's 2a? Be minus 9.8. Okay? So I have my calculator. Let me use it. Actually, I don't need the minus 20.5 divided by 9.8 equals 2.5. Okay. So that means that point right there, excuse me, this point has an x-coordinate of 2.5. But what they're asking for is the y-coordinate. So how do I get h of t for the vertex? Yeah, in other words, what I really want is h of 2.5, right? In other words, I want to know what the height is at 2.5 seconds. I've already calculated that the vertex is going to occur at 2.5 seconds. So I want to know what that height is. So it's minus 4.9 times 2.5 squared plus 24.5 times 2.5 plus 2. You do or you do not have a calculator? What are we working on? Number 10? Well, I could go through. I have a calculator, but I don't know why we would waste time doing that. First of all, we're almost out of time. So you can come up with a number, okay? And that's going to be a positive number. If you get a negative number, you got problems. You've done something wrong. So that number that you come up with is going to be that height. That's the maximum height that ball goes. Find the time when the ball hits the ground. What am I going to do that? First of all, tell me the logic I'm looking at. This is the height. This is the height formula. When the ball hits the ground, what's the height when the ball hits the ground? So I'm going to set that equal to 0. Because that's when the ball hits the ground. The height's going to be 0, right? And only then. So I now have this quadratic formula equal to 0. You got lots of practice with solving quadratics equal to 0. Most likely, I would say you're going to have to use the quadratic formula because we're looking at fractions and decimals, and it's very unlikely that this thing would factor nicely. So just go ahead and plug it into the quadratic formula. You're going to get a plus and a minus answer. Let's just say we come up with 3.6 seconds. That's when the ball hits the ground. Well, what's the plus minus? What am I doing with that? Which one am I going to use? Yeah, there's no such thing as negative time. So the negative answer cannot possibly be right. Why do we get a negative answer? Because we're looking at something like that. That would be a negative answer, but that's when the ball hits the ground, right there. Okay? If you were to backtrack and go backwards in time, you would see that it starts on the ground at minus whatever the answer negative sign was. But it doesn't really leave there. It never was there. It takes off at 2 meters. In other words, you throw it up, comes back down. So the negative sign, just know that time or dimensions can never be negative. Whether you're doing geometry or projectile motion, if you get a negative answer, discard it and use the positive answer only. You good to go, or you got any other questions? Let's just look at the last question they asked there. Find the time when the ball is 20 feet above the ground. Well, what am I going to do? We don't need to solve it, but tell me how I would solve it. H of t is the height. So if they want to know when it's equal to 20, that's what I'm going to do. And then I'm going to solve that quadratic. Notice that it all comes down to solving a quadratic. Now, you solve that a little differently than you do when it's equal to 0. In other words, you got to move the 20 over to the right side so that I do have 0 on the left. And then you got to use the quadratic formula again. And that would tell you when the ball is at 20 feet. Now, obviously, look at this picture. There's 2 places where it's at 20 feet. There's there and there's there. It's going to be at 20 feet going up. It's going to be at 20 feet coming down. So you better come up with two answers for this one. And again, they actually want the times. In other words, they're asking about what times is the flight of that ball 20 feet high. Now, in actuality, because we're going straight up and straight down, it goes like this, but there's still two places where it's 20 feet, right? It's on the way up and on the way down, assuming the maximum height is above 20. I think we proved that. Then there's going to be two answers for when it's at 20 feet. It's going to be going on the way up and going on the way down. Now, these problems are actually a little harder when you throw a ball straight up and straight down. It's a little more understandable when it actually looks like projectile motion. In other words, when it looks like a parabola, because you can see that there it's going up 20 feet and there it's coming down at 20 feet. All right. All right. Brianna, I will let you go. Are you on your phone right now, right? Before I let you go, let me just try one thing. Just as an experiment, if you don't mind. Won't take but 2 seconds. Assuming I can write. Yeah, okay, here. I want to see what portion of my screen you can read. Can you read that digit? Tell me what it is. How about that one? How about this one? Don't see that one? Oh, well, you do see it. Okay. And how about this one? Just trying to get a feel as to whether you see my entire screen, and it looks like you do. I was concerned with that on your phone, because on my end, I'm looking at 12 inches across. So I wanted to make sure that you see everything, which means everything must be a little bit smaller than the size I'm looking at when I look at it. In other words, I'm looking at a big 1746 here. You must be looking at a tiny one since you're on a smaller screen. But as long as you see the whole screen, so far, if you had any problem with numbers that I've written, in other words, them being too small for you to read, okay. Well, seems like it works on a cell phone. It's just, I've never seen it from your end. It's hard for me to imagine that it would look as good on a cell phone just because the phone is so small. When Samsung comes out with their foldable screen, they're coming with that for a couple, in the next 2 months. Samsung's coming out with a cell phone that you open up and you have basically an iPad. Yeah, it'll be really cool, where you get twice the screen size for the same size cell phone. I think that'll make a big difference. But for our purposes, it looks like this works just fine. Yeah. So, Brianna, I hope you're feeling better, and I will talk to you next time. And, yeah, tell your mom that she's always welcome to call me to schedule an appointment, but if she goes on to my website, Digital Math Tutor, you can do it online. It'll show you all my available time, and it'll let you pick whatever time you want. Okay? You're welcome, Brianna. Talk to you next time.